Work problems. Some word problems concern machines or workers and how fast they can get certain jobs done. The fundamental equation for this is remarkably similar to the d equals rt equation that we saw in the motion problems. The work equation, I'll write this as A equals RT. A is the amount of work done. R is the work rate, the rate at which work is done. T is time. Some people remember this as art. Any kind of work, it's a sort of art that you're doing. That helps some people to remember the equation. The amount A can be products manufactured, or houses painted, or pizzas made, etc. The work rate could be the number of products per minute, or houses per day, or pizzas per hour, etc. So different work rates would be expressed, obviously, in different amounts and in different amounts of time. As with the d equals rt equation, it's important to be able to solve this equation for all three variables. A equals RT is already solved for the amount. If we solve for the rate, that would be rate equals A over T. Or if we divide by R, then we'll get the time equals the amount divided by the rate. And just as it's important to switch between those three forms for the d equals RT, it's also important to switch between these three forms for the A equals RT. There are two broad categories of work problems. One type involves using proportions. Of course, the work rate, like any rate, is a ratio and can be used to set up a proportion. For background, see the rates and ratio and rates lesson in the percents and ratio module. If you haven't seen that lesson already, I highly recommend taking a look at that lesson first. The other type involves multiple machines or workers working at different rates and figuring out how much work these get done together or apart, something along those lines. Here's a practice problem with the first type. Pause the video and do this without a calculator. A machine working at a constant rate manufactures 36 staplers in 28 minutes. How many staplers does it make in 1 hour and 45 minutes? So this looks like it could be challenging to do without a calculator. And if you did this without a calculator, you might have found yourself working with very big numbers. Let's talk about how to avoid running into such big numbers. So, first of all, I'm going to change that time to 105 minutes. So everything is in minutes now. So we're going to set up a ratio, staplers over time. So 36 over 28, that's the initial ratio that we're given. And this is going to be S, the number of staplers, over 105 minutes. Well, first of all, it would be a mistake to cross-multiply right here. To cross-multiply, do 36 times 105, then 28 times S, and then trying to divide that gigantic number by 28. That would be a nightmare. Please do not make a mistake like that. So do not start by cross-multiplying all those big numbers together. Instead, simplify the fraction on the left. That's a very good place to start. 36 and 28 are divisible by 4. Cancel the 4. We get down to single-digit numbers 9 over 7. Much better, but we'd still like to cancel more to make that 105 smaller before we cross-multiply. Another huge mistake, we cannot cross-cancel between the 9 and the 105. That is an absolute nightmare, wrong thing to do. And many people think that you are allowed to do that. Now, if this is all brand new to you, I would suggest go back and watch the video Operations on Proportions, where we talk about this in great detail. Instead, we can cancel the 7s, a factor of 7 in the two denominators. So we're canceling across the denominators. And again, if this move is unfamiliar to you, go back and watch the operation with proportions. That's really an important video to understand if what I'm saying about proportions here is not familiar. So we cancel the 7s, and we get down to 9 over 1 equals S over 15. Well, now it's ridiculously easy. Now we can cross-multiply. We get S equals 9 times 15, so S equals 135. This is 135 staplers. So notice that once we did enough canceling, it was very easy to do without a calculator. If you know the legitimate operations with proportions, and you remember to set up the ratios with the matching units on both sides, so stapler over time, then there aren't many curveballs the test can throw you with these proportion questions. They're relatively straightforward. The other type with multiple work rates can be more confusing if you're not familiar with it. So pause the video and think about this problem, then we'll talk about it. Okay, to detail a car means to clean it thoroughly inside and out. When Amelia and Brad detail a car together, one car takes 3 hours to detail. When Amelia details the car alone, one car takes 4 hours. How long does it take Brad working alone to detail one car? If you don't know the secret to handling this question type, these questions can be confusing because most of the simple arithmetic operations one might try don't lead to the correct answer. The secret to problems involving different machines or workers working at different work rates is this. The combined work rate of people or machines working together is the sum of the individual work rates. In other words, we add the rates. We can't add or subtract the times. We can't add or subtract the different amounts made in different times. Those are the numbers usually given in the problem. We have to construct the rates and add or subtract them. Very important. So we'll go back to the question, and the rates that we're going to look at are cars over hours. How many cars per hour? So the rate of A and B together is a rate of 1 over 3, 1/3. They do one car in 3 hours. And Amelia working alone has a rate of 1 over 4. That's her rate. And so it must be that when we add the two individual rates, they add up to the combined rate. And so that means that Brad's rate alone, that must be the combined rate minus Amelia's rate alone. And so that's going to be 1/3 minus 1/4. Find a common denominator, subtract, it's 1/12. So Brad works at a rate of 1 car in 12 hours. So in other words, it takes him 12 hours to detail a single car. So that is how we solve an equation like that. Here's another one along these lines. Pump X takes 28 hours to fill a pool. Pump Y takes 21 hours to fill the same pool. How long does it take them to fill the same pool if they are working simultaneously? So pause the video, think about this, and then we'll talk about this. Again, what we need to do is figure out the rates and then combine the rates. So here the rates are going to be in pool per hour. So we're talking about the same pool, that single pool in how many hours. The rate of X working alone is 1 over 28, one pool over 28 hours, and Y working alone is 1/21, one pool in 21 hours. We're going to get the combined rate by adding those two individual rates. So we're going to add them. In order to add them, we're going to find a common denominator. Notice that 28 is 4 times 7, 21 is 3 times 7, so we'll multiply the first one by 3 over 3 and multiply the second one by 4 over 4, and that will get us to a common denominator of 84. That is the least common denominator, the least common multiple. When we add in the numerator, we get 7 over 84. That cancels down to 12, so that is the combined rate. So that means that they're working together, they do one pool in 12 hours. So it takes them 12 hours together to fill the pool. For work-related word problems, use A equals RT. A is the amount, R is the work rate, T is the time. For proportion-related work problems, you need matching units on each side, and you need to understand the operations with proportions. For problems with multiple workers or machines, create rates for each one, and then add the rates.